Hello and welcome to another screencast by Teach Me to Code. This is Eric, and today I'd like to talk about something that I've run into recently, which is how to handle processes and completely detach them and run them as background tasks. So first thing I want to show you is the process class within Ruby, and that's what we're going to be using. Basically, here, let me show you how this works. I'll kind of explain it as we go. So here we have P1, which is assigned right here by fork. When you call fork, it actually returns the PID of the child process that you're running. And just to show you that we do have a parent process, I'm going to put parent PID is process.pid. Now, process, anytime you call process .pid, it will return the current process that you're running. So let's go ahead and run that, and you'll see that it does return 5026, which is the process of the parent. So let's take a look and see what we have here. I'm going to modify this a little bit so that we can actually show the process. Child process process.pid, and we'll have it sleep, and we'll do the same one for this as well. Actually, I need a close quote. So we'll do the same one for this as well, so you can see that we do have two additional processes. And right now we have process.wait excuse me, process.wait PID, and what that'll do is it'll actually hold the I'll explain that in a second. Actually, what I'm going to do is just this right here. So I guess it didn't show anything because I didn't do a put s. So there we go. So you see we have a process parent, which is 5045, and two child processes, 5046 and 5047. Now the parent processes of both of these right now is whatever this process is. And when we end that, let's say we undo this, comment this out, and we want to print out the current state of the process of that PID, of the children PID. If we print that out, you're going to see, okay, well, first off, it's set to S, which is, I believe, not complete. But let's wait a couple of seconds. Okay, so here you see the Z, and the Z stands for it's a zombie process. Now, in the documentation here it says some operating systems, not OS 10, but some operating systems like I know for example, I know CentOS does this, will retain the status of a terminated child process until the parent collects that status back, either through a wait or whatnot. And this is called, the child that stays around is called a zombie process. And those can build up and build up and build up, and we don't want that. So what we do is you can have process.wait. So if I uncomment that and run this again, you'll notice that only the process that did not have the wait is now a zombie. But this kind of brings in a problem. Let's say instead of we sleep for that short a period of time, why don't we sleep for, on the second one here, why don't we sleep for 5 seconds? And go ahead and run that. So you see what's happening is that the actual process itself is completely stopped. And that's not what we want. To kind of explain it a little better, you see we have, let's say this is our process line right here, and right here is where we want to call the process that we're going to fork. So we fork this, and it comes out and it runs. And what happens up here is that we do not leave this point until it comes back and says, okay, we're done. So once that happens, then this continues on. But what we want to see is we want to see a something that looks more like this, to where we have a process call, and when it comes off, it just shoots off, and then there's no there's no stopping point. So this continues and this continues simultaneously. So how do we do that? All right, let's talk about it here. First thing we can do is something called a detach. So if we did a process.detach, and let's say in the first one we did a wait PID. Alright, the first one we did a wait PID, so let's say this one is still 0.1 seconds, this one is 5 seconds. So if this, so you're going to notice that it returns an immediate response. No, there we go. So it returns a pretty immediate response after that 0.1 seconds. So we didn't have to wait the full 5 seconds for it to return that response. Now the difference here is that it says that it is still running. So instead, why don't we do this, and we'll just put these in a loop and have this sleep for 1 second and run that again. And then we're going to be able to see, okay, well, it's running, it's running, it's running, now it's gone. So you see that that process did exit properly, which closed it out. So that is the first part of what I want to talk about. The second part is I want to introduce a way that we can actually run scripts in the background without having to slow down the foreground, and we're going to use this process to do it. Okay, I've copied some code in here which I'll walk you through, but as you can see here, as before, we're printing out our parent ID, and I want to loop through this 10 times, and in each loop I want to fork a process which will call a script. So I have some script.sh and I'm passing in my PID and an ampersand to let it run on its own. So let's take a look at that script. All it is a simple bash script which takes the parameter that gets passed in, echoes it, sleeps for 10 seconds, and then echoes it again saying that it is complete. So as we go through here, you see we assign the PID to that fork PID. We sleep for 5 seconds. After that, I just want to print out the PID of the child process right here. Then I set up the script, which I pass in the PID. So all of this so far is just preparation. Now here you're going to see exec script if fork is not nil. Now typically I don't think it's I've never run into a case where you actually need to have this. So the reason I believe we have this right here is because if all else fails, if it was unable to fork it, we're still going to call that exit properly so that it will continue on with the process. So it's going to execute the script. Now the script itself will run in the fork process, and the script should exit properly. So you could say exit 0, and that should exit properly. But just in case it doesn't exit properly, or just in case the fork is not nil, or fork is nil, it will still exit and continue. And then down here you see we detach that process, passing in the PID, and then after that I just have some stuff that's being printed out. So here you're going to see, let's take a look at what exactly this will look like when it runs. So I'm going to run that. So you see after 10 seconds, actually I'll let this complete and then we'll discuss it here. Okay, program exited just fine. Everything went well, and that's exactly what we wanted. So you see at first we have it print out immediately starting child process, but that actually happens after 5 seconds. So you see we run this every second. So the first iteration we call before fork, create a child process after fork. So right here is when that initial child process starts running. Now it's still going to wait for 5 seconds before it does anything, before it actually initiates it, because of this code right here. So we see 5 iterations of this, and then after that we're going to start seeing the processes start, and then after that the processes stop. After 10 seconds the processes stop, and then you see down here we say after fork. Actually, you know what? Let me do this. end of script, actually end of parent script. And this is really important to see when we complete our parent script. So let's run this again. Right here. So you see we've ended the parent script already. So from here on out, all we are is observing the child processes, and that's not even within this Ruby script. It's actually within the shell script. So that is a solid way to spawn child processes. The way we use it is we actually have an MQ server, ActiveMQ, which we submit the response of those child processes to, so that the parent can catch up to it. But I hope that you learned something. This was definitely a fun experiment for me. Very basic stuff, but it's also it was challenging to see how fast we can get this going. This screencast is sponsored by Jumpstart Lab. Jumpstart Lab offers private and corporate training in Ruby, Rails, and related technologies. They're experienced educators, not just good developers, and will get you going quickly. Courses can be scheduled in the U.S. or around the world, and curriculum customized to meet your needs. Learn more at jumpstartlab.com.
That was wonderful.
Bravo!
I loved that.
Oh, it was great.
Well, it was pretty good.
Well, it wasn't bad.
Well, there were parts of it that weren't very good, though.
It could have been a lot better.
I didn't really like it.
It was pretty terrible.
It was bad.
It was awful.
It was terrible.
Get him away!
Hey, boo!
Boo!